You're live.
We did it. We're live.
Hello.
Whoa, this is a new layout. Okay.
It's different.
So Pamela, you I guess people can't hear you, but oh man, if I'm gonna have this like conversation, a one-sided conversation.
I will add my audio.
There we go. You know, that's what I like. Pamela is a incorporeal voice behind the scenes. The ghost in the machine.
She doesn't want to be on camera today.
She went through a lifetime of being on camera over the Hangout-a-thon. So I think she deserves a break from at least being on camera, but not being a disembodied voice that haunts us all.
So y'all have a choice. I can either make you pretty or I can be on camera. You don't get both.
Right. And then we've got a nice place for a picture. What's that? The Veil Nebula?
Yeah.
Is the Veil Nebula going to be our because if you like put a picture up there, then the pressure's on to find a different picture to put up there when something changes.
I have a whole slide deck. I'm good.
Oh man, wow.
So
I feel bad. I
Is
feel
that
super
visible in the night
guilty.
sky right now? Can we see that out there if we go and look?
I have no
Yeah.
idea.
The
Ah,
veil.
I'll have
Hold
to try
on.
and find out. I'll have to
Wait,
try and
no, it's summer because
Summer?
it's in Cepheus, right? The veil.
Cepheus? Okay.
Yeah, and it's a summer constellation.
Got
I'm
it.
thinking, like, whenever we do the virtual star parties, we bring up the veil in the summertime.
Got it.
How does
Great.
it happening, the star parties? Like, do you have a telescope and you make a video of it and then you stream it? Or how does it work?
I mean, we haven't been doing them
It's
for a
in
while.
Cygnus.
So
Fraser.
Cygnus, okay. Yeah, the
Yeah, it's part of this. It's part of the Cygnus loop.
Right, part of the summer triangle. Okay,
I knew
yeah,
it.
so
I knew
still
remember
summer.
Oh, but
that.
that's on the
Okay.
sky. We can see that still early. You
You can still see it right now. Yeah,
Yeah, right now. Yeah.
yeah, and the veil is a supernova remnant. It's one of the largest objects. It's huge in the sky. It takes many images to actually take pictures of the whole thing.
Cool.
So with the star parties, so I was remotely connecting into a telescope and then displaying and downloading the images that we were taking and then just displaying them on my streaming software.
To
Oh, that's
which
really cool.
telescope?
The telescope was in it was a remote telescope. It's a Celestron Rasa 11-inch, which is an astrophotography telescope with a Celestron mount, but we haven't done the star parties in quite a while. It just sort of, we were hoping that we'd solve the problem. We're still just having too many technical difficulties. So my new plan, I don't know if you guys all know, but I'm building a new studio. We've moved into the countryside. I'm building a studio, and part of the plan is to actually build a little observatory. And then I will install a telescope, and then I will do star parties from here. And
Yay.
and well, yeah, I mean, we'll have rain and clouds every.
I was
I was
going
going
to
to
say,
say, how are your
how is
skies?
this going to work? Yeah.
yeah. Yeah. My skies are abysmal for half of the year.
We're so lucky here in Southern California. It is wonderful so much of the time.
Yeah.
So blessed.
I think like San Diego was like the absolute perfect weather for me. It was like not too hot, not too cool, right on the ocean. Oh, it's so nice down there. Yeah.
Yep.
Yeah, I could live there.
Yeah, the city where I live, I couldn't see anything. But I went to holiday recently to Greece, and it was nice.
That's awesome.
You could see a lot.
Okay, I think we've reached the 5-minute mark. So why don't we start this up? Let's see. Okay. All right, let me get my intro, and here we go. Hello and welcome to the Weekly Space Hangout for Wednesday, October 27th, 2021. I'm Fraser Kane, publisher of Universe Today. This week, we're going to be talking about a planet in another galaxy, measuring the atmosphere of a planet 340 light years away. Planets. Everything that's coming up to see in the sky in the fall. 20 years of Proba 1 and Artemis I is fully stacked. All right, joining me this week, I guess, with this new layout where everybody's just on the screen, there's like no surprise now. So I'm just going to like point. Let's see, is it this way? Yeah, there we go. So directly to my right, left. Everything's mirrored and flipped. So I got Beth Johnson. Hey, Beth.
Hey, Fraser. How's it going?
Good. I mean, we talked over the summer, but this is the first time we've actually been back doing a show together. So
This is the first time I've been on camera doing a show with you because I'm producing Astronomy Cast now. So
off
camera in your ear all the time.
That's right. You've been the disembodied voice in the back of my head. But yeah, it's good to see you back. And then we got Pam Hoffman. Hey, Pam.
Hello.
And first show with you this season. Welcome back.
Thank you very much.
Yeah, and then we've got Veronica Klimovich. Hey, Veronica, welcome back.
Welcome back. Happy to see you.
So you guys are all grizzled veterans at this point. So we've done many seasons, and so this should just go beautiful, smooth. I've been too easy on you for the previous seasons, so now that you're like at least 2 seasoners, it's time to crank up the complexity and
Time
and
for
the
the deep
questions.
end. Okay.
That's exactly it. Yeah. So prepare yourself.
Okay,
All
so
right.
so we're at the defending our thesis point. I see. Got it.
That's exactly it. Yeah.
I've never done that.
So we were going to have a special guest, but our guest had an emergency. So I know Nancy's going to attempt to reschedule that. So hopefully we'll have the guest slot back in at some point in the future. I hope everything's okay.
You have Dr. Diapert soon too.
We
The
do?
space juggler. Yeah, I helped make that happen.
Oh, did you? Okay. I don't look forward too far into, like, I don't want to freak myself out, and so I just prepare myself for the day. I don't really look that far in advance. But a space juggler. Okay, you know what? No spoilers. We'll wait for them to show up, and we'll find out how juggling and space come together. I am intrigued.
Yeah, it's
all right.
super cool. They can't hear me, but it's super cool.
Now, before we get on to this week's show, I just want to give a huge thank you and shout out to our good friends at the Weekly Space Hangout crew. They are our fans. They are our executive producers. They work behind the scenes to organize everything so that we don't have to. But if you want, if you love the idea of bringing on astronauts and astronomers and space scientists and NASA administrators and space celebrities, all you have to do is join the Weekly Space Hangout crew. You immediately get your executive producer credentials, and you can then reach out to any guest in your imagination. And of course, because you're an executive producer of a TV show, they absolutely have to come on, and that's how you bring on the guests that you want. So join the Weekly Space Hangout crew. Go to wshcrew.space, and they'll give you all the information that you need, as well as your executive producer job title. All right. So let's get on to this week's space news. Beth, you are there first in line. Let's talk about a planet in another galaxy. What?
This is so exciting. When this one came across my news feed, I had to stop and read it a few times. So basically, they used X-ray telescopes, so ESA's XMM Newton and NASA's Chandra, and they examined X-ray binaries in the Whirlpool galaxy. So it turns out that there's not a lot of X-ray sources that are hard to differentiate when you're looking at another galaxy. So it's pretty easy to kind of pinpoint what they are and where they're coming from. You can't do this with visible light. So the normal methods that we would use, like the transit method, looking for a dip in that light source, won't work because for the purposes of a telescope at that distance, it's just kind of one ball of light. So there's no real way to differentiate objects. So instead, they looked at X-ray binaries, which are basically a really dense object like a neutron star or a black hole, and then another star that's basically being torn apart. Sorry, star. But it's getting all of its material sort of pulled in by this denser object. And as it gets pulled in, it's accelerated, it heats up, and it lets off light in X-rays. And so we can see those X-rays. Easy peasy part. This is where it gets kind of cool. So what they did was they looked for dips in the X-ray light. So it's still kind of a transit method. And what they figured out was that the dips could be explained by a planet. Now, they had to rule out a bunch of other stuff. And this isn't to say that this is a planet officially, but nothing else really worked. So they looked at, could it be a smaller star, like a brown or red dwarf? And they said, no, system that they're looking at is too young, and the transiting object would be too big. So then they
why
said,
why too young? Why too young? Why are they saying it's too young?
So let me.
And how come only one? Really, only one?
Well, one so far.
One so far. Okay.
Yeah, one so far.
Yeah,
I mean,
the first one ever.
This is the first one. So this is kind of like this is that leading edge discovery. And as we kind of find out in astronomy, like you find one and you start finding more of them over and over and over again.
That is so cool.
Yeah, the Whirlpool Nebula is like what? The Whirlpool Galaxy, sorry, is like 60 million light years away. And so
wow. Andromeda's a million, yeah.
Yeah, or 2.5 million. Yeah. So all of the planets that we find in the in the Milky Way are within, say, 10,000 light years of Earth. And so to find one that is tens of millions of light years away is phenomenal.
And why didn't we find one in Andromeda first? Because that's much closer than any. It's like the closest other extra galaxy to us.
Well, I think it's just that happened to be what they were looking at.
Okay. Right.
I think this kind of becomes one of those, we're looking for something else and we found a thing we weren't expecting and now we think we know what it is.
Oh, I love that sort of thing. The happy accident stuff.
Yeah.
Yeah.
So when I had originally heard the story and I hadn't dug in too deeply, my impression was that it had to do with gravitational lensing. I know they had done some gravitational lensing surveys in the past and had theorized that there were planets. Like, essentially done an overall survey of an entire galaxy and gotten the sense that there were probably planets in there. And I'd assumed they would have that they had made the discovery using gravitational lensing, and so it's just a one-time event. But in this case, if it is an X-ray object that's in orbit with a star and the star has a planet, they can just keep watching it for as long as they want.
Yeah, well, the planet though seems to be orbiting every 70 years. So, but it did block out the X-ray light for a significant amount of time. It was like several hours, and then the signal came back. So it's kind of pretty neat how they did this, and it also echoes how we discovered the first planets in the exoplanets in the solar system, because that was found around a pulsar and was actually examined in X-rays as well for part of that discovery. So this is kind of neat because it could be the start of a whole new field. So looking forward to seeing where this goes.
So how was it examined as well? Is it like, did they use the same method before, or is it completely new method what you're
No, it's pretty much the same method. They're just using X-ray light instead of visible light. So they're just looking at it in different wavelengths. And Fraser, the article makes a point of saying that it's not a cloud of gas and dust.
Right. Which it always is in the first place. So so you've got this X-ray source, which is pretty tricky to observe anyway, using Chandra, and then it's dimming as something is passing in front of it, and then as that thing is passing in front of it, it's further dimming because of the presence of a planet. Incredible.
Yeah, it's mostly the planet. The star's not causing any of the dimming. It's the planet going around the star. Passes in between that source.
Oh, incredible.
Bess, do you know why the star isn't a factor with the dimming part? Is it also
because because it's going around at a different rate, so they're not watching that transit. They've seen it transit though. They have seen the star transit the object before.
Oh, interesting.
Yeah.
Wow.
That's really cool.
This is a great time to be alive. There's so many cool things happening. It's so exciting.
Yeah, I mean, just to think, I mean, that we have, I mean, it's not conclusive, but we are pretty sure we've detected a planet in another galaxy.
Yeah,
still.
Yeah, this is, it's one for the history books. Awesome. All right. Pam, why don't you tell us what's coming up in the fall skies?
So, and I like to talk about things you can do, and we have 4 meteor showers coming up. So I'm going to give a little bit of an overview, and then I'll kind of deep dive into it. And here's the meteor shower chart, which I created. But I'll talk about the 4 coming up. There are about 900 known, and I have on the chart there is 13. You only hear about 2 a year though on the news. So anyway, the overview is
wait. So sorry. There's how many meteor showers?
Well, they know of 900. They verified about 100. And these are the 13 that are kind of like the best ones to do anything with. You're personally go and looking, and you only hear about 2 on the news because those are the biggest and brightest. Clearly the good ones, but still there's more to the meteor shower world than the 2 you hear on the news.
And where do you get the information normally?
What's that?
Where do you get this information from?
You know what? I curate information from all kinds of places. I use the Old Farmer's Almanac a lot. Of course, there's all kinds of websites out there, and you know, like any kind of curated thing, you have to pick and choose. And these are the 13 on most of the lists that you find out there. I just put them together. I figured might as well tell everybody about all 13 for the year. Plus, it makes it almost one a month instead of having to wait for 2 a year, that kind of thing. So yeah,
Or you could have 3 a day with 900.
Well,
possibly.
it's a little more complicated than that because that's actually research that I worked on. I've actually confirmed a meteor shower, so
Oh, really?
I can't wait to hear more from you, Beth. That's so cool. I would love to know all about that. That's amazing. I don't know anything else about it except for there's supposedly 900 and they have been able to verify 100 of them.
So how do you confirm the meteor shower?
you have to observe it repeatedly. So sometimes what we get are these what they call a meteor burst, which is just you've passed through a debris cloud and we don't know what it came from. We don't know if it's something we'll go through again, if it's just sort of, Earth's orbit isn't perfect all the time. So it's, sometimes you go through a different little area and you pick up, some rocks that were there and that's what you go through. So it's really hard on some of these transient meteor showers to know if there's something that we're going to pass through again. But if we do, then you can say, yeah, we've seen this one a couple times, or, you predict that we're going to go back through it again and it happens, then you can say, yes, this is a real meteor shower. It happens regularly.
So I might be updating my list if we ever get to talking, Beth.
That's awesome.
So cool things you can do. Of course, every Wednesday is the Weekly Space Hangout. I have a show on Friday nights. The 4 meteor showers are coming up. There's a partial lunar eclipse and opposition.
So sorry, can you just, with the meteor showers, which was the next one that's coming up?
Sure. We can talk about that.
Yeah,
I was
you
just going to do
mentioned
the
there's a
overview
bunch.
first and then dive in.
Oh, sure. Either way.
All right, since we're on the meteor showers, we've got the southern Taurids, the northern Taurids, the Leonids, and the Andromedids. And is there a way to enhance that chart to make it a little bigger? Yeah. Oh, I think the next one down, Pamela, is kind of zooms into the main ones. So that what you saw before is the whole chart, and these are like the 4 that are going to be available to you kind of between now and the next show that I'm on, which is about a month usually. So November 5th, look for the peak of the southern Taurids. And then and we have things like when can you see them? Mostly after midnight. 10 to 20 of them appear, and I don't have a source for the meteorites. And each of these have kind of a range. September 10th to November 20th is kind of, you can see them in any part of that time frame. Oh, and I don't see where it radiates from. Often there is a kind of a specific place that they appear to be coming from. In this case, there isn't a specific one. Of course, maybe Beth can help me out and fix my chart for me. So Northern Taurids, those range from the October 20th to December 10th. The peak is either November 9th or November 10th to 11th. Those are good because they're in the late evening and they have their radiant is from Taurus. We have 2 sources apparently from that. It's 2P and Enki. Help me out, Beth.
That's the full name. So it's Comet 2P/Enki. That's
it's one. I thought it was 2. I'm so glad you're here. All right, so then we've got the Leonids. They are November 6th to the 30th, and they peak. Again, this is sort of the time you'll see the most, November 17th, 18th. After midnight, they seem to appear from Leo, and there's 10 to 20 an hour. And again, is this 55P/Temple? Is that one?
Mm-hmm.
Yeah.
That's one comet.
Okay. All right. I'm so glad you're here. And then we have the Andromedids. I don't have a range for those. We get the peak time around November 25th, 27th, again after midnight, because a lot of times it's the Earth kind of coming into this field. That's pretty small, 5 an hour, and Biela, I think, is the source. Is that how you say it, Beth? Biela?
I'm not sure on that one. That's not one I'm familiar with. This is a new one for me.
But
okay.
Any night that you have dark skies, if you look up in the sky for a few minutes, you should see a meteor.
Yeah. Actually, you can see them at any time. And they say you can see them at any time, especially in that range. The peak is when you might see the most. And honestly, I want to see a meteor storm. That's the one where it looks like it's raining from the old lithos.
Yeah, the last big one I think was back in the 1960s. I think it was like 66 or something like that. There was a Leonid, I think it was a Leonid storm, and people were seeing thousands of meteors an hour.
People have told me about others that were a little more recently.
I think there was a Leonid that was in the 90s, because I think that was when they took the predecessor to Sophia up and did some observations from the sky of the actual meteor shower.
Yeah,
Yeah, I
it
think
was in
that's the one I've been hearing about.
2001, I think, or 2000, 2001. So I know I had already started Universe Today when that one happened, and it was good. I was in Vancouver and was able to see still, I would say, like one a minute. So maybe it was 100 an hour or so, and it was, but it was very bright. They were quite impressive. It was quite a show. And I've never seen a meteor shower that good. Yeah, we're totally overdue. That and a bright comet.
Cool. All right. So then we have a partial lunar eclipse that is on November the 19th. The area that you can see it, and that's the next. That'll be the next slide, Emma. The areas, and you can go and do some searching for this kind of thing. We're seeing it. Let's see, let me get my chart out because I can't read that one. Northern and Southern America, Australia, and parts of Europe and Asia. They have some really cool animations on, and I put it there, timeanddate.com/eclipse/lunar/2021. I just did eclipse November 2021, and you get lots and lots of sources, and they have some really cool animations and some stuff from before that you can look at. It's wonderful.
Well, the problem is that partial lunar eclipses suck.
I mean, you're not
Why is that? Oh, they're hard to see. They're hard to see.
That's the. I mean, these animations are great, but I wouldn't get out of bed for a partial lunar eclipse.
Got it. Okay.
Yeah.
Well, I'm sure there is some.
If you tell me there's a partial lunar eclipse in the sky right now and I'm outside, I'm not even going to look.
Yeah, David Dickinson will tell you they're worth looking at for pictures, and I'm sure scientific things.
Yeah, I'll have that argument with him anytime, anywhere.
Yeah, okay.
Yeah.
All right, and then there is an opposition. It is with Uranus, I believe. I have lots of notes here because there's lots of conjunctions too. I won't go into every single one of those, but I will put them in the comments after the show. Yeah, here it is, November 4th. Uranus is at opposition, and as you can see, and here really every year we get, at some point in our orbit we're at opposition with all the planets. In this case, it's going to be Uranus on November the 4th. But this is the point at which we are between the planet and the sun. So it is opposite the sun from us. Yeah.
So what do you see in opposition? Is it like interesting to watch?
So it's pretty much the closest approach, and also the kind of the best time to take photos of things. And I know Uranus isn't very bright, but if you do have some, pretty decent equipment, I would give it a try, because that's going to be, really the closest we are to the other planet in our orbit and its orbits. They're always a little bit different. So, yeah. These are kind of just some significant things I want to make sure people know about, and if you want to try them out. But the next one I have is called Globe at Night. I think that's our next slide here. Hope. Yes, I did it right. All right, this is really cool because either you can go out with your phone or you can use your computer to go out, take a picture of a specific target, and they give you a 10-day period to do that in, and they pick the target for the Northern Hemisphere and for the Southern Hemisphere for each 10-day period of the month. And you take the picture and then you say, okay, it looks like this. And they give you like 6 options. So it helps them kind of gauge what the skies are like. And this is a real concerted effort by, tens of thousands of people all over the planet to help us understand what our night sky is like now. What is it? What are we seeing? What's possible? That kind of thing.
So we can
And so,
chart our depressing loss of the night sky.
sadly, that's probably too. However, we can fix that. There are ordinances, like in it's Northern California. What's the name of the observatory there?
Lick
They have.
Observatory.
Which one is it?
Lick Observatory. I live in San Jose, so I look up at the hill at it all the time.
Okay, so Lick has some probably ordinance, and this one's in Northern California, Northern Arizona though. Flagstaff. It's in Flagstaff. Of all the places around it, you must have the proper lighting around that particular observatory. So targets for October 27th through November 5th, and we're in it now, is the Perseus for the Northern Hemisphere, and Grus, I've never even heard of this, this constellation for the Southern Hemisphere. So anybody know anything about the Southern Hemisphere? I'm always intrigued by stuff I can't see, I guess.
I've only seen it once. So I've been to Australia once, and it was great to see all these constellations, as you say, that I just only the Southern Cross, Alpha Centauri, the Omega Cluster, the small and large Magellanic Clouds. So it's amazing, but I've only seen it once.
Got it. Okay. And of course, the other significant thing I think about is kind of the phases of the moon, because of course, if it's kind of bright, it's going to be harder to see some of these wonderful things that are faint and fuzzy, like globular clusters and open clusters and nebula and stuff, because you can actually find them with binoculars, a small telescope. I actually found Andromeda last night, naked eye. And then I actually found it with the telescope. That's like the second time I've done that myself. I've seen it other times when other people have, found it and presented it through their equipment.
Wow.
But I was like, because I'm teaching a class, I'm back live and teaching a class, and I was like, I found it. I was so excited. So last quarter moon is on the 28th. We've got, I have to scroll through. I have a lot of stuff here.
We're running out of time. So
okay. Full beaver moon is on the 19th, and the new moon is the one you really want. And that is, sorry, this is a whole new format. Nope, we won't get one for a while. Oh, there it is. What is that? November the...
Good night for a star party. That's funny.
Yep, that's right. That's exactly right. And that's what I scheduled.
It looks like November 6th.
November 6th. Thank you very much. All right, so that's good. I will put the rest in the chat after the show.
Fantastic. Awesome. Thanks, Pam. All right,
Welcome.
Veronica, now let's go with your second story first, which is the fact that Artemis I is fully stacked. This is pretty exciting.
Okay. Very well then. So since 2004, NASA is trying to work on the launch system that will send astronauts to the moon. First time since Apollo. And in 2011, the Space Launch System was proposed. And it is the heaviest and the most powerful rocket since Saturn V. And together with the Orient space craft, it is building up Artemis program that you all guys know, I'm sure, which is the sustained lunar exploration and even crewed missions to Mars. So there were several doubts that the SLS will be ready on time due to some delays and cost overruns. But luckily, ground crew and the engineers managed to stack the Artemis I mission in the Kennedy Space Center in Florida. And the vehicle is now ready for the last phase before the flight. Uncrewed flight to the moon in February 2022. So the fully stacked Artemis I rocket includes, as I mentioned earlier, space launch system, the rocket boosters, the Orion spacecraft, and the European Ceres module, which is the European Space Agency's contribution to the Artemis mission, and we Europeans are really proud and happy to take part in the Artemis mission. And the delivery of this European service module was all over the news here in Europe. So, and The European Service Module includes the propulsion system for the capsule. It includes consumables like air and water. It has the power in form of solar arrays, and I think it's on the next slide. I think it's the next slide as well, where I could see the parts. Yeah, all right, that's one. And you could see also like the thermal control system that will keep astronauts comfortable for the future missions. And there is also avionics, which is the brain of this module. So now that the space launch system and Orion capsule and European service module are all integrated together, they will undergo like a series of tests to evaluate them as the one integrated system. And there are various tests that will be done until the February 2022. And NASA will announce a date for the launch once the last test, which is called wet dress rehearsal, is successfully concluded. And I've basically skipped a lot of tests that needs to be done before that. But if you're interested in, go to the Universe Today and read it in the latest article.
That's a good site.
Yeah, it's a good site.
Yeah, there are a lot of
Got my information from there.
Oh, good.
There are a lot of safety tests. I used to work at Boeing on the Delta rockets, and yeah, tons and tons of tests, like constantly.
Well, especially when you're talking about something that's eventually going to be crewed, it's all of the tests and then do them again.
Please do, yes.
So yeah, that is exactly what this first Artemis I rocket is gonna do, is actually test and validate all this equipment, the launch system, the capsule, the European service module, and other systems for the crewed missions in the future, which are planned with this Artemis II project, a mission, which is like 2023 September. And Artemis 2 is going to have people on the board, but the people would not land. But hopefully with the Artemis 3, which is planned for September 2024 currently, we finally gonna land on the surface of the moon. However, there are some delays related to this date. So we are not sure that the Artemis 3 would be on time, which is fine. We can still concentrate on the NASA can concentrate on Artemis 1 and Artemis 2. So it looks like it's going well.
So Beth, I know you're following this story and you've been working on this for Daily Space. Place your bets. Do you think it'll launch?
Do I think the February
year?
22 one is going to launch?
Yeah,
I think the February 2022 one is probably pretty solid, but I don't think Artemis 3 is going to happen when they say it's supposed to. Artemis 2 is I'm hesitant to say that that's going to happen when it's set. I'm honestly amazed the thing is stacked. Okay.
Yeah.
Well, I mean, they did we saw the hot fire test earlier this year. We've seen Orion has already flown to space and returned to Earth in a test mission that happened a few years ago. So it's all the pieces are there. What do you think, Veronica? What do you think the pressure is from what Starship is doing? We've heard Elon Musk say that he's expecting to launch Starship in probably within a month to go orbital. And if that works and it's successful, now you've got a fully reusable rocket that has similar capabilities to the SLS. What kind of pressure do you think that has for the long-term chances of the Artemis program?
I had like two different ideas right now in my head when you asked this question. So the first one would be like, okay, it is a pressure definitely for the NASA because they were developing this expensive projects like for a while now, and now you have something which is much more cheaper and working. So it's like kind of maybe sad for them, but on the other hand, they can concentrate on the other stuff. So let's just share the work, and everybody will actually only be happy about the work together. So the NASA will concentrate on one things that the SpaceX cannot do now, and the SpaceX do the cheap flights and bring stuff to the moon. And if it's gonna happen, why not? The
Yep.
more people fly, the more companies fly, the more countries fly, the more information we get, and the quicker we will be there where we want.
Oh yeah, totally love all the commercial, everything. That's good.
I didn't know that you worked with Delta
Yep.
rockets. What did you do on them?
5 years. I was at Boeing for 5 years, and we worked on everything between the guy sitting at the computer and the rocket. All the umbilicals, all the computers, all the systems for that. It was wonderful. I supported about 25, electrical engineers at one point. It was called Electrical Ground Support Equipment. That was our
That's
division.
amazing. Wow.
Yeah, that's cool.
Wow.
In Huntington Beach, California.
Why did you hide that part of your resume in the conversation? You're always talking about space or something, but what we can see in the night sky. But oh, by the way, you supported 25 rocket launches. That I feel like you buried the lead there, Pam.
Yeah, I ground a mirror for a telescope. Yeah, it's just stuff you do in your life as you go along.
I literally have not talked to a person who has supported as many launches as you have. So that's actually really kind of amazing.
We have to do an interview with Pam.
Yeah, we gotta have Pam. We gotta put Pam in the hot seat. We'll talk about working on.
I confess
on
that
Delta rockets.
that my father is a retired rocket engineer.
Oh
wow!
He worked for Martin Marietta before it became Lockheed Martin for
that's neat.
Almost 2 decades, I think.
That's
really I bet cool. He has some cool stories.
He has some really cool stories. He won't let me record them or have him on camera.
He might not be allowed to share. He might not be allowed to share outside.
Well, I mean, even the stuff that he can share, he just won't let me. He won't. He just says no. Like we've tried. Annie and I have begged so many times, and he's all no.
No. No. Those are his stories, not your stories.
Gotta stealth it.
Yeah.
Set up a hidden camera.
Yeah, that's awesome. All right. Well, that's awesome, Veronica. I do hope that Artemis launches successfully, and they have many successful launches. I feel like the whole series is going to be under increasing pressure, but we'll see what happens. Beth, let's go on to your second story.
Okay.
Speaking of exoplanets.
So when I say this story is hot off the presses, I mean that I got this press release in my email this morning. So
I noticed it this afternoon. So yeah, you beat me by a couple of hours.
Yeah, so I haven't actually had a lot of time to go through it. It was sort of you need a second story, and I'm all, well, I was going to cover this one anyway. So basically what has happened is a team led out of university or Arizona State University has analyzed the composition of the atmosphere of an exoplanet called WASP 77AB. It's a hot Jupiter. Temperatures are upwards of 2,000 degrees Fahrenheit. It's a U.S. university, so of course it released it in non-science units. Okay, so they basically observed it. So they've seen it with Hubble, but this time they used a specific instrument, the Gemini South Telescope, which is called the Immersion Grating Infrared Spectrometer. And if you think that's a mouthful, they put that down into an acronym of IGRINS. Scientists cannot be trusted to name things.
Wait, did you say IGRINS?
Yes.
IGRINS.
Yes.
Right.
Immersion Grating Infrared Spectrometer, IGRINS. Yes.
Right.
I cannot make these things up. So basically what they did was they used that particular instrument to basically take spectra of the planet, which we've done, but usually it's fuzzier. And the way that this new instrument is designed, it actually can measure the amount of water vapor and carbon dioxide in the atmosphere. So instead of getting sort of fuzzy spectra, you get very, very clear spectra. So that's like that's an improvement on the technology. This is one of those things where a certain telescope that shall not be named is supposed to be helping us with these things, and it's not up in the air. So
Oh,
everybody's trying to work on all of the ground-based telescopes to improve their instrumentation and do the things that they were hoping to do. So they have figured out that they have actually calculated all of the relative amounts of oxygen and carbon in this particular exoplanet's atmosphere, and everything matched up with the star. So they got the amounts that they expected. And so that's really nice. And now basically what they want to do is they want to take this instrument and look at like 15 more planets, measure their atmospheres, and start building a catalog of exoplanetary atmospheres and start seeing where the similarities are and differences and what systems give you what. And so it's sort of the start of a big project, it looks like.
it boggles my mind what spectrum can do. I mean, this is just the colors of, I mean, you can tell if it's going away from you or towards you, or the atmospheric composition, or it's unbelievable the things that you can get from spectrum. So if you want a science to go into, people,
Yeah.
that's a good one.
Yeah, it's applicable for everything. Everyone I know uses it in some fashion. We even started using it in meteor shower observations. We started taking
Oh,
spectra of meteors as they came in. So
I think I saw about that. Yeah,
It tells you
yes,
what they're made out of.
yeah,
Yeah.
the color.
exactly, and
If you
especially because they're burning up, so it's really easy to get the spectra out of the flames, and it's great.
yeah, well, even just looking at them, sometimes you can see a color, and if it's one color, it's copper, and if it's another color, So yeah, they're different.
I wonder if that's like when you see, say, a meteorite that's turning green or a meteorite that's more purple or whatever, and you are seeing sort of what they're made out of. Is that like a rough version of the spectra? Like
Yeah,
when astronomers are breaking up the light and they're seeing absorption lines and emission lines and so on, that's
I
just
think
the
it'd be
same.
very rough if it is.
Yeah.
yeah, it's a basic. It kind of gives you like a few options for some of the contents of the meteor itself, so that's a helpful start. And sometimes it can kind of even with that can give you like what kind of meteor it was in some of the bigger general categories.
I think
So
that's a great way to express it as a helpful start.
so back to this planet.
Yeah,
So you said they found water, and what else did they find in the atmosphere?
carbon dioxide.
Carbon dioxide. Okay. But of course, it's 2000 degrees in Fahrenheit, so uninhabitable. But still, the fact that they found water vapor in the atmosphere, they found carbon dioxide. And this is, I mean, I think this really plays into the future of searching for habitable planets. That the way we're going to find out if these planets maybe even have life is searching their atmospheres for biosignatures. And so the more examples, I can imagine some future where, I mean, they've analyzed not one but thousands, and they're seeing this interesting collection of spectra across all these different planets, and
So how do you get
some will start
biosignatures out of
to.
that though, Fraser? I don't quite
Well,
get.
there's
Oh,
I actually have an answer to that. There's actually a
cool.
group that is putting together a database of molecules that you can find in planetary atmospheres and trying to figure out which ones would be most likely biosignature markers. So
Mm.
signs of biological life of some sort, or even potentially technological signs of life. So
So,
there's
but
actually
our kind of life, or kind of like a variety of kinds of
a
possible life.
variety of kinds of life. So they're
Oh, good.
looking at like what does a lot of plant life give you? If you have a lot of green plants, what kind of signatures are you expecting to see in your atmosphere? If you start having pollution, what kind of signatures does that give in your atmosphere? So that kind of thing is sort of what they're doing, and they're building a database of these kinds of things. So this planet actually just sort of adds to that database too, of what you can find in an atmosphere, and then what does it signify on the surface necessarily. So
How about
they're
things like silicon-based life? Are we going to talk about that at all, or is it just kind of
Well,
carbon-based?
I mean, I think the issue is that we're looking for some kind of the presence of some chemical in the atmosphere of the planet that is out of stability. And so if you
Mhm.
look at a planet like Venus, or you look at a planet like Mars, you see carbon dioxide and stuff. There are perfectly natural processes that can generate those. But if you have something like methane, methane only lasts for a couple of hundred years in the atmosphere of a planet. There has to be some source that's producing it to make it out of whack. You look at you measure the Earth's atmosphere and whatever we have, 20 something percent oxygen. There has to be life that is generating that oxygen to produce that much oxygen in our atmosphere. So we don't know what the life, how it will behave, but you're looking for the presence of just some kind of chemical in the atmosphere that you can't get it from volcanism, from solar radiation, from just natural processes. There has to be some kind of life that is doing chemistry, that is pumping the atmosphere in some artificial way, and that's what they're going to be searching for.
Okay.
And the other issue is that we have a sample planet of one, so we have to kind
Yeah.
of go with what we know. And so until we find other things to examine, we're sort of stuck with, well, we know what life looks like here. And
Yeah.
but I do know of a few researchers that are working on trying to find how to detect the building blocks for other forms of life. So it is something people are working on. It's very difficult because you're working on a question where you don't even know the answer.
Like Southern Hemisphere, Northern Hemisphere. People say, "Oh, why can't you talk about the Southern Hemisphere more?" And I'm like, "I've never been there.
Yeah.
How do I talk about it? I understand perfectly."
Yeah, absolutely. All right, well, let's go to our last story before we wrap up for today. Veronica, talk about Proba 1.
Yep. So 20 years ago, the first ESA small satellite, Proba 1, was launched with only one goal: to prove innovative technologies. So it was intended to survive only 2 years, but it remains still fully operational right now, and
Wow.
it made this instrument, this satellite, the oldest serving Earth-observing satellite of ESA. So the Proba 1 is roughly a size of a hotel fridge, approximately 6U by 6U, like CubeSat size. And this Proba 1 satellite introduced various novel then, but now mainstream technologies, like commercial off-the-shelf parts. Or it was the first spacecraft that was having full automated capabilities that required minimum ground control. Or it also had the first lithium batteries on the board. Or it had gallium arsenide solar panels. And also it used the star tracker for gyro-free attitude control. So some of the names that we are currently hearing, like to be used in various satellites, but back then everything was new. So the Proba 1 marked kind of a change towards small satellites in European space industry. So while CubeSats are currently very common and available, back then the Proba 1 was actually the ESA's first small satellite. And the mission was developed in only 3 years, which at the time, when missions often took more than 10 years to launch, was like extraordinary. And in addition, Proba 1, as I already mentioned before, was the first one to fly the lithium batteries. Back in 2000s, the experts would prognose only 6 months of lifetime for these batteries. And now, 20 years later, the team don't see any degradation of the batteries, and the battery is like 23 years old, and it is considered the longest operating lithium batteries in at least low Earth orbit, maybe even in space. I'm not sure about that one.
So we saw some of the pictures that were there on the screen, and you could see like the pyramids. Like it's a pretty good little Earth observing satellite. And its images have been used in a bunch of science articles and research as well. So it's
Yeah,
quite impressive how long they've been running this spacecraft.
yeah, for 20 years. I was so surprised. And if you look at this picture that I also upload, because I thought, okay, maybe the quality is not that good, yeah, but when you look at it, it's pretty good. You can actually do some scientific research on that, and it was like 20 years ago. And that was like what I wanted to add, that why they called it New Space before New Space. It's basically this mission was carrying a lot of off-the-shelf components, which was at that time something very special, and nobody did it. So 20 years ago, commercial parts were considered to be risky and not reliable. So this spacecraft, the team proved that having good engineering, you can use like commercial off-the-shelf parts, and you can fly 20 years in a harsh space environment. And that is the proof of the concept that these parts are more cost-effective and time-effective than the high-graded ones.
Yeah, COTS was a pretty big deal once upon a time with everybody. They call it Spring March, and in the spring, a bunch of space people will go and lobby directly, personally, to the folks in the United States who are our Congress and senators and stuff. So, yeah, I know some of those folks.
Again, another part of your history that we weren't aware of. That's awesome. It's funny that, like, it's only been 20 years, and so to have this, as you say, small refrigerator sized spacecraft to launch then, and now we have CubeSats that are like the size of a paperback book. Like, they're teeny tiny little spacecraft.
Are the Starlinks CubeSats? They're not They're not CubeSats, are they?
No, they're much bigger.
Okay.
Yeah,
Because I know they're small. They're not regular satellite size.
Yeah, they're sort of weird and flat, and
you could fit 60 of them in a fairing.
You could fit 60 of them in a launch fairing. Yeah. So if you sort of imagine a launch fairing that is 5 meters across, so they are all racked up. So they're probably about 2 meters long, and then racked up inside the launch fairing in a way that fits 60 of them.
Interesting.
That's too impressive. Cool. Like 60 of them.
Yeah, totally. All right, well, we're nearing the end of our hour, so before we move on this week, I want to give each of my co-hosts a chance to shamelessly self-promote something that they're working on and where people can find out more. Beth, what are you working on, and where can people find out more?
All right, I can be found pretty much everywhere on social media as @PlanetaryPan, except for Insta, which is @planetary_pan, because Insta. The thing that I am excited to be presenting will be coming out this Saturday on the SETI YouTube, and it is a special grudge report that my colleague and I did on John Carpenter's The Thing. So we are overanalyzing the science of a horror movie.
What time on Saturday?
It'll premiere at noon Pacific, so I'll have that up and ready to go then. And so we're kind of excited about it. We've been doing sort of some spooky science over at SETI, and so this is sort of the culmination of our week, of our 2.
That sounds cool.
That's fantastic. Pam?
Great. Yeah, we got our show Friday nights, and that's 9 p.m. Pacific time. We're visible on a couple of places, the Everyday Spacer Facebook page and the Everyday Spacer YouTube channel. And basically, we've got 3 guests lined up. Josh Carlson, he's going to be Friday. He's the author of Space Power Ascendant. He's going to talk about space development theory. Daniel Klopp is going to be with us on November the 5th. He is a real spacesuit guy. He's going to talk about developing spacesuits and EVA suits for NASA and the next generation of spacesuits too. Say that 10 times fast. Dr. Adam Dipert is coming back. He's going to be talking about the helium-3 experiments, not the space juggler. We had him before, and he talked about space juggling, but he's going to be back on the 19th. And he's going to talk about his helium-3 experiments. I can't wait.
Awesome. Veronica.
Yeah, to be honest, I haven't done a lot of social space, but I privately did a lot for myself. I applied to become an ESA astronaut, and
Oh, right on! Congratulations.
and
That's
I
awesome.
got into the next stage. So I
Did
was
you
doing
really?
my test
Oh,
Saturday.
good.
Congrats.
Congratulations.
That's great.
Yeah, and it's like a long process, but I was fully concentrated on that, and it takes all of my free time currently. So very
Go for
exciting
it.
for me, but not a lot of social work,
That's
unfortunately.
amazing. Yeah.
Go for it. You can do that
Yeah.
stuff later.
That'd be
Yeah, that's
incredible.
awesome.
If
That's a
you
big
became
deal.
an astronaut, that'd be amazing.
Yeah, I would be so happy as well.
And then we'll do the first weekly space hangout from space.
Yeah.
I agree.
Yeah.
I agree.
Yeah, we'll do it. Yeah, you got to let us interview you if you actually pull that off. All right. So I've got an interview on Friday morning at 8 p.m. my time. I'm interviewing one of the scientists working with the Perseverance rover. We're going to be talking about the collection system. So how does Perseverance collect samples? How are they prepared? How are they stored? And how will they be returned to Earth? So we're going
Who
to
is
go
it?
deep dive into all of those kinds of questions.
Who
So
is
what
it,
was?
Fraser?
Oh, let me just look at the name.
I'm just wondering if I know them.
Justin Simon from NASA.
Oh no, I don't.
He's
know
from
Justin.
JPL. So there you go. And then of course I'm Universe Today. Got all the things. UniverseToday.com. Sign up for my weekly email newsletter. Post on Twitter. Hang out on the live show over on YouTube. So, all right. I think we've reached the end of our hour. So thank you everybody for joining us this week. Big thanks to Pamela for engineering this week's episode behind the scenes. It's man, I mention this every week, but it is so great to have the pressure off me to be trying to engineer the show at the same time that I'm trying to host the show. I actually feel a little like I don't know what to do with myself. I'm just like just sitting here, just talking to people now, as opposed to madly trying to manage all the streams. So it is definitely a relief to have Pamela working behind the scenes. Thanks to Beth, Pam, Veronica for being my co-host this week. It was always a pleasure to hang out with you guys. Thanks to all the mods on YouTube and on Twitch. And we will see all of you next week. Thanks, everyone.
Bye-bye.
Thank you. Bye bye.